Hello, this is Mrs. Scarple back with part 2 of topic 3.13, our trigonometry and polar coordinates. In this video, I'm going to focus on complex numbers. So you have been introduced to complex numbers being numbers written in the form of a plus bi. A and b are constants. And when we graph complex numbers, we're graphing them using a rectangular grid. So the a value is like x, the b value is like y. So if I have the number 3 plus 2i, I'd be 3 on the horizontal axis, 2 on the vertical axis, and that's how I would graph that complex number in the rectangular coordinate system. Well, in my prior video, I talked about in the polar system that we can find x by using r times cosine of theta, and we can find y by using r of cosine of theta. So that just means that the r times cosine of theta, even though we equate it to x, that's going to be the a of the complex number, and the r times sine of theta is going to be the b of the complex number. So here we have in example 6, the complex number -2, -2. So we need to find our radius, our radius basically, that's the r, but we also need to find our measure for the angle. So let's start with finding r. R is just using Pythagorean theorem, but remember, I'm just going to go ahead and write it as the square root of -2 squared plus -2 squared, and that's going to be the square root of 4 plus 4, or the square root of 8. And because we don't generally use square root of 8 when finding our sine and cosine values, we have it in terms of square root of 2 or square root of 3. I'm going to write this in its simplified form of 2 square root of 2. And then for theta, that's going to be tangent of theta is y over x. So I'm using the arctangent, the inverse of -2 over -2, which is going to be the arctangent or the arctan of 1. Now tangent is positive in the first quadrant and in the third quadrant. So we need to decide which measure do we want. And in the third quadrant is where we would find the point -2, -2. So I don't want to use pi over 4, which has a tangent value of 1, but what I actually want to use is 5 pi over 4. So now that I have r and I have theta, I can express this point as a complex number. So my a value, or the x of my complex number, is going to be that 2 square root of 2 times the cosine of 5 pi over 4. And then we're going to have plus I times 2 square root of 2 times the sine of 5 pi over 4. And I'm going to simplify those values because I know using my unit circle what the cosine ratio is and what the sine ratio is for 5 pi over 4. So we're going to have 2 square root of 2 times 5 pi, cosine of 5 pi over 4, because it is in that third quadrant, is going to be a negative square root of 2 over 2 plus I times 2 square root of 2. The sine is also going to be negative root 2 over 2, since it is in that third quadrant. When I multiply, the 2's will cancel that are in front of our radicals. Square root of 2 times square root of 2 is 2, so we're going to have negative 2. And then same thing will happen over here. We'll have another negative 2, but now I'll put that I behind, like we normally write variables. When we have the radicals, that's when we have we leave the I kind of in front, but because I have an integer here, I'm going to write it as 2I. So the complex number for the point negative 2, using the trig, using polar coordinates, is negative 2 minus 2I. Now, I know some of you might say, but couldn't we have done that anyway, just knowing that if 3 plus 2I is right in this first quadrant, that negative 2 would be negative 2 minus 2I. Well, this is using the polar coordinates to also verify that that should be the case. And then we have in example 7, where we're going to identify the x and the y values. We're just going to, again, simplify within these expressions. So to find x, that's going to be 4 times the cosine of 7 pi over 6 is going to place us in the third quadrant. That's going to be a negative root 3 over 2. 2 will cancel with the 4, so x ends up simplifying to negative 2 square root of 3. And then for y, you're just going to take 4 times sine of 7 pi over 6 is going to be negative 1/2. And 4 times negative 1/2 is negative 2. So we have our x value, we have our y value. If we write it as an ordered pair, that's going to be negative 2 square root of 3, negative 2. And we have our rectangular coordinates from a complex form that was written using the sine and cosine relationships, or the complex number form. And this concludes all of the information for topic 3.13.